हेलो गाइस, वेलकम टू माय चैनल आईपीसी एजुकेशन। आज हम चैप्टर नंबर 1 रियल नंबर्स क्लास 10th की जो एनसीईआरटी की बुक है उसके अंदर हमारा ये सेकेंड वीडियो सेशन है जिसको हम आज लेने जा रहे हैं। तो पिछले सेशन में हमने देखा था कि यूक्लिड्स डिवीजन लेमा से हमने एचसीएफ निकालना देखा था। तो यहाँ अब हम कंटिन्यू करेंगे एग्जाम्पल नंबर 2। तो एग्जाम्पल नंबर 2 है show that every positive even integer is of the form 2q and that every positive odd integer is of form 2q plus 1 where q is some integer. So according to Euclid division lemma, we used to write a is equal to bq plus r, where a and b are integers, q is quotient and r is remainder, and the value of remainder is always greater than equal to 0 and less than the value of b. So in this question, let a be any positive integer and as we can see, we have to show that every positive even integer is of the form 2q. That means with q the value of b is 2, or every positive odd integer is of the form 2q plus 1. That is again here this 1 may correspond to the value of r, and 2q, that means again q is there and b value will be 2. That means the value of b is 2. Then by Euclid's division algorithm, we can write a is equal to, in place of b that will be 2, in place of q it will be as it is plus r. Clear? For some integer q value is greater than 0 and r value will be, if suppose we divide any number by 2, we will get remainder is either 0 or 1. And from where I am getting this value? I told you r value is always greater than equal to 0. That means it can be 0, right? It is equal to 0, and r value is greater than 0 but less than b. So our b value was 2, so less than 2 we get numbers 0 and 1. So r value will be 0 or 1. Clear? So we can write r value is either 0 or 1 because r is greater than equal to 0 and less than b, that is equal to 2. So a can take value 2q plus r, that is for first time taking 0, or a can have value 2q plus r, this time we take value 1. So either it can have value 2q or it can have value 2q plus 1. So if a is of the form 2q, it means the remainder is 0, and I told you for every even integer how to tell whether the even integer or odd integer. We tell by dividing it the number by 2, and we find that if remainder is 0 then the number is even, and if the remainder is 1 then the number is odd. It means this value is remainder. It means if remainder is 0 then a is equal to 2q. That means a is any positive integer. So a is any positive integer whose remainder is 0. It means a is an even positive integer. So if a is of the form 2q, then a is an even integer. And if A is of form 2q plus 1, that means remainder is 1. If remainder is 1, then if a number is divisible by 2 and its remainder comes out to be 1, then it is an odd integer. Clear? So coming to example 3, show that any positive odd integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. So according to Euclid's division lemma, the value of a is equal to bq plus r, where a and b are some integers, q is the quotient and r is the remainder, and value of this remainder is always greater than equal to 0 and less than the divisor b. So I can see here in the question we have to show that positive odd integer is of the form 4q plus 1 or 4q plus 3. It means, see, if I compare this with bq plus r, I see that plus r can have values this, right, and bq. So both these terms contain q, but they contain the value 4. That means we begin the question by taking the value of b 4. So let a be any positive odd integer, and we apply the division algorithm. We will apply this division algorithm, right, by taking a and b equal to 4. By taking a and b value equal to 4, we apply division algorithm. Now if b value is 4, then my r value will be somewhere greater than and equal to 0 and less than b, that is 4. It means the value of r can be 0, greater than 0, but it is less than 4. That means it can have value 1, 2 and 3. So looking at this, I can say a can have values. See, if r is 0, r is 1, r is 2 and r is 3, the value of a will change. So a can have values, right? In place of b I will put 4. So 4q plus r 0, that is 4q plus 0. So 4 in place of b it will be 4 only. So 4q plus r value can be 1. 4q plus 1. Next time 4q plus 2 or 4q plus 3. Since if it is an odd integer, we have written that a is any positive odd integer and q is quotient. So a cannot have values (4q plus 0 and 4q plus 2), because remainder cannot be 0 or 2 if an odd integer is divided by 4, right? So therefore any odd integer will be in the form of a cannot have values this 2, 4q plus 0 ये नहीं हो सकता है, 4q plus 2 ये भी नहीं हो सकता है. सो a की सिर्फ 2 वैल्यूज बची है, तो a के कौन से वैल्यूज हो सकते हैं? एक any odd integer will be in the form of either 4q plus 1 or 4q plus 3. So coming to our next example, that is example 4. A sweet seller has 420 Kaju Barfis and 130 Badam Barfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is maximum number of burfis that can be placed in each stack for this purpose? So it is simple. This type of question we used to find the HCF of the two given numbers, that is 420 and 130. But as of 10th standard, we will find out the HCF using Euclid's algorithm. So using Euclid's algorithm, to find HCF of 420 and 130. So as I told you that day, the number which is greater will have the value of A, and the number which is smaller will take the value of B. And we will represent this number in the form of A is equal to BQ plus R, where R value is greater than equal to 0 and less than B. So A is 420, B is 130. So multiplied by something plus you will get remainder. So it means we have to divide this number by 130. So 420 divided by 130. 130 3 is a 390. You will get here 30. It means 130 multiplied by 3 plus the remainder, that is 30. Since remainder is not equal to 0, we will change the value of A and B. That is, this time the value of A will be 130 and B will be 30, and we will proceed in the same way. That means we will divide 130 by 30. So 3 4s are 12, that is 30 4s are 120. Now I am getting remainder 10. So 30 multiply 4 plus remainder is 10. Since remainder is again not equivalent to 0, so we will divide this 30 by 10. That is, this will be my A value and this will be my B value. So 30 equal to 10 multiplied by something plus this. So clear it is. 10 multiplied by 3 is 30 and I have to add 0. 10 3 is a 30 plus 0 is 30. So it means the value where remainder is 0, at that place the value of B, A is equal to BQ plus R. That means where remainder becomes 0, at that time the value of B, see this is BQ plus R, BQ plus R. So the value of B where remainder becomes 0 is our HCF. So HCF of 420, 130 is which one? Remainder is 0 at this stage. So value of B at this stage is 10. So this is 10. So therefore the sweet seller can make stacks of of 10 for both kinds of burfi. For both kinds of burfi, you can make stacks of 10. To exercise 1.1, question number 2. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5, where q is some integer. So in our previous section, we have solved a question, show that any positive odd integer is of the form 4q plus 1 and or 4q plus 3, where q is some integer, that is example 3. So you have to proceed as per example 3 and solve the given question by taking A any integer, that is positive odd integer, and B value will be, compare here, BQ plus R, BQ plus R, BQ plus R. So B is 6. So proceed by taking B value 6. Clear? Next, an army contingent of 616 members is to march behind an army band of 32 members. In a parade, the two groups are to march in same number of columns. What is the maximum number of columns in which they can march? So maximum number of columns, it means we can find out HCF, right? So you have to find out HCF of 616 and 32. And how to find HCF, I have already discussed in our first video, right? So you have to find HCF of these two numbers by using Euclid's division algorithm. Or you can prefer in this video also the example 4. I have found out HCF of two numbers using Euclid's division algorithm. So proceed as per example 4. Now coming to question number 4. It is given, use Euclid's division lemma to show that square of any positive integer is either of form 3m or 3m plus 1 for some integer m. So in the hint section it is given that take in x be any positive integer. Suppose x is any positive integer, then it can be written in the form bq plus r. Clear? And comparing this with this, I can find that b can have values of, see, q will be m, r value remainder here I can write plus 0 plus 1. That means here if I compare, I find that b value is equivalent to 3, right? So I will begin my question by taking x as any positive integer which will have b value as 3. So q will be there, plus r. What will be the values of r? So here r will have values greater than or equal to 0 and less than b, which is equivalent to 3 now. So r can have value, see, greater than 0, less than 3, and it can be equal to 0 also. So r can take values of 0, 0 के इक्वल भी हो सकता है, 0 से ज़्यादा भी है लेकिन 3 से कम है. तो 0 हो सकता है, 0 से ज़्यादा मतलब 1 भी हो सकता है, 2 भी हो सकता है, लेकिन 3 नहीं हो सकता क्योंकि 3 से क्या है, ये कम है. So r can have values 0, 1 and 2, right? So in that case, if I take first r value as 0, so x can have value 3q plus 0, 3q plus 1 and 3q plus 2. Clear? So x can have these values. Now we will do square of each and we will try to show that square of this positive integer is either of form 3m or 3m plus 1. So first I will begin with x is equal to 3q. So squaring both sides, I will get x square equal to 3q square, that is x square equal to the square of 3q, that is 3 square and q square. So 3 square is 3 multiplied 3, 9, and q square is q square. So square of this 3q is of the form 9q square, and now I will convert it. So I can write it in the form 3 multiplied 3q square. If I take this value as m, because they are given for some integer m, so let my m value be 3q square. So 3q square has changed to m, so this will become 3 multiplied by m. So for first case, the square of this integer is giving the value of 3m. Clear? So now I will take the second one. Now if x value is 3q plus 1, again squaring both sides. So here I will get x square 3q plus 1 square. So here most of children get confusion. They will do square of 3q and they will also do the square of 1 and they will add it. So here you have to apply the formula of a plus b square, that identities we have read in standard 8. So a plus b square is equal to a square plus 2ab plus b square. We will apply this formula over here. So x square equal to this. The value of a here is 3q. So 3q square plus 2 multiplied by 3q multiplied by 1 plus 1 square. So x square is equal to this square of 3q square, you are done here, that is 9q square plus 2 3 6q, multiply by 1 you will get 6q, plus 1 square is 1. So here I can see here common is 3, q is also common, but I am taking 3 only common, so I will get 3q square plus 2q plus 1, because I have to represent it in the form of 3m or 3m plus 1, so I have to take only divisor value as 3 only, so that is why I am taking only 3 common. Clear? Here I have to take, why I am taking only 3 common, because the divisor value in the question they have given 3m or 3m plus 1, we have to show in the form of 3m or 3m plus 1, and in the beginning I told you the value of b is equivalent to 3, the value of b is equivalent to 3, that is divisor value will be 3, so that is why I am taking only 3 as common. So here 3 is common, this value I can take as value of m, so 3q square plus 2q will be m plus 1 as it is. So first part I have solved, the first part is represented in the form of 3m, second part, that is 3q plus 1 is also represented as 3m plus 1. Now our third part, if I will represent this third part in the form of either 3m or 3m plus 1, then our question is solved. See, to show that square of any positive integer is either of the form 3m or 3m plus 1. So I have to proceed with the third part, and if I will solve this third part, then our question is solved. So coming to the third part, x value is equal to 3q plus 2, right? Again I have to square on both sides, that is squaring both sides. I will get x square equal to 3q plus 2 square. Now again I have to apply formula a plus b square, so using identity a plus b square, that is a square plus 2ab plus b square, right? I will apply over here, so x square is equal to a square, that is 3q square plus 2 multiply by 3q multiply by 2 plus b square, that is 2 square. So 3q square, that is 3 square, and q square, that is 9q square, 2 to the 4, 3 is 12q plus 2 square, that is 4. Now again I can see in all this I can write it in the factor form as 9 can be written as 3 multiply 3, right? Q square, that is I am keeping as it is. This 12 can be written as 3 multiply 4, q as it is. I told you divisor is 3, that is why I will try to take out the common 3 from this, right? So, and plus 4 can be written as 3 plus 1. Clear? So in this section, in this much part of the question, I can take 3 as common. So what is left? 3q square, 3 taken out from here, taken out from here, and taken out from here, right? So 3q square plus 4q. Here nothing is there, it means I can write 3 ones are 3, right? Still value is not changed. So 3 is taken out, what is left? 1. So this part I will consider as m. So let m is any positive integer, right? So sorry, m is any integer, so m can have value 3q square plus 4q plus 1, right? So in place of this I will substitute m, and so my question is solved. That is, if I will take x value as 3q, then I can represent it in the form of 3m. If I will take value 3q plus 1, then I have represented it in the form of 3m plus 1, and I have now taken 3q plus 2, and again I have represented in the form of 3m plus 1. So from this I can say that from the result of 1, 2 and 3, we can conclude that we can conclude that square of any positive integer is either of form 3m or 3m plus 1 for some integer m. Clear? Last question of this exercise. Use Euclid's division lemma to show that the cube of any positive integer is of form 9m, 9m plus 1 or 9m plus 8, where m is again some integer. Right? So for this question, you will say that we can take the value of, suppose our Euclid's division lemma says that a is equal to bq plus r, and r value is greater than equal to 0 and less than b. So as per this, if you compare this with this, right, you will get bq plus r, that is 9m plus 1, 9m plus 8, and here nothing is there, so 9m plus 0. So if you compare, you will say that b value is, see, plus r, it means whatever is the part of plus over here is the value of r, right, and this is together bq, that is 9m, 9m, 9m. So I can say q value is taking every time the value of m, so b value will take the value of 9, right? But I know that if any number is divisible by 9, it means it is divisible by 3. So we will not extend the question up to 9. So for simple, to solve this question, we will take any positive integer a. We will begin our question. Okay, so begin question by taking any positive integer a and b value as 2. If b value is 2, then the r value will take the values greater than equal to 0 but less than b, that is 2. So if b value is 2, my r values can have the value of 0, 1 and b value we have to take 3. I told you because 9 is divisible by 3, so it means every number that is divisible by 9 is divisible by 3. So if it is the case, b value is 3, right? So r can have values equal to 0, greater than 0 but less than 3. इसका मतलब r जो है वो 0 के बराबर भी हो सकता है, 0 से ज़्यादा भी हो सकता है, लेकिन 3 से कम होगा. यानी 0 से ज़्यादा मतलब 1, 2, 3, 4 कुछ भी, लेकिन 3 से कम. ठीक है, तो इसलिए r can have values 0, 1 and 2. So if I put these values, so a can have values, in place of b we will write 3, q is unknown quotient and remainder will be 0, right? Or it can have values of 3q plus remainder this time 1, and a is equal to 3q plus 2. So these values, these three values it can have. Now simply you have to find the cube of this number and try to make them in this form. If you will make them in this form, then you can show the given question. That means we have to show that the cube of any positive integer is of form 9m, 9m plus 1, 9m plus 8. So you just find out the cube of this and try to adjust it to this level, as we have done in the question. Previous question, we have found out the square of that number using the identity or directly, and after finding out the square, we have adjusted to the form 3m plus 1. Like that only you adjust it in the form this by taking out factor, right? So in this way you can solve this question.